Hello and welcome to another edition of Ontology Talk. I'm Adam Pease. Today I'll be giving a presentation in three parts that covers first what is an ontology and then two brief descriptions of applications done with Sumo. An ontology is like a dictionary for computers to read. A normal dictionary has concepts with words as labels and definitions that are in natural language. Different concepts can often use the same label. A word like run a race or a run in a stocking. An ontology, however, has unique labels for different concepts and definitions in math that a computer can manipulate to answer questions using software called a theorem prover. I worked for a large internet commerce site with offices in a dozen countries. They did careful A/B site testing to determine whether each change to their site increased sales. A randomized portion of traffic would automatically be sent to the candidate new site. They did rigorous statistical analysis to determine if the change in revenue was positive and significant. But they recorded experimental conditions just in emails and slides to present to their decision makers. With experiments happening in many different groups in different countries over years, people had no way of knowing whether a different group had already done a similar experiment or even had reached an opposite conclusion. Managers couldn't make the best decisions because they didn't have integrated data. I worked for an internet travel company that had been in business for 10 years and grown to 600 employees. The original developer of their database was still there. At one point he said quietly that their database had 15,000 fields. 1/3 were no longer used, 1/3 were wrong or out of date, and 1/3 were in active use by their application, and he didn't know which were which. This is not a rare occurrence. Most databases are not well documented. Developers assume that others will have the same context or talk to them when adding and naming fields. But then scope changes, new people start adding fields or writing code to use the data. Suddenly it's not so clear anymore, even if people add a few words to explain their intent. Our computers can't help determine if data elements are consistent or redundant when the meaning of a field is captured just in its name or in a few words of explanation. In contrast, definitions in our ontology are captured in math. Each new term is linked to a library with thousands of other definitions that can be inherited to give a full understanding of the intended meaning. A computer can prove mathematically whether each new field is redundant or conflicting. This is essential as databases grow ever larger. No human will ever be able to keep thousands of definitions consistent without automation. Thanks for watching this edition of Ontology Talk. If you found this interesting, please like, subscribe, and share, and go to ontologyportal.org where you can find out more information. Thanks for watching.